The second part of this note is focused on factoring polynomials completely. And this can be a little bit awkward at first whenever students are tasked with factoring completely. And the reason that is because you've seen all the polynomials in nice, neat little boxes. You only saw trinomials. You saw trinomials that factored to be a bi times a bi. You did a bunch of those and that was it. Then you saw difference of squares pattern, and you didn't see any of those trinomials that factored to be a bi and a bi. You saw perfect square trinomials, and you had 10 problems that were nice, neatly packaged perfect square trinomials. Now, what we're going to see is everything mixed together. So you have to learn how to look for the patterns that you saw before with all the different types and try to make sense of what approach to use when you're faced with a particular problem. So the first thing you want to do, anytime you're faced with a polynomial and you have the direction to factor, is you want to factor out common monomials. First, always check to see if there is something that can be factored out of each. So if you have something that looks like 2x squared plus 4x plus 10, the very first thing you're going to want to do in every polynomial is see, is there something I can factor out of all of them? In this case, you could factor out a 2, which leaves you with x squared plus 2x plus 5. But regardless of what you end up with, always check that first. The next step you want to do whenever you're factoring polynomials is identify the pattern. What pattern are you looking at? And if you think about it now, we learned a pattern for factoring binomials. And the binomials we learned to factor were a squared minus b squared. And we remember that if it's a difference of squares, it's going to factor to be a binomial times a binomial, a plus b and a minus b. So you're going to check to see, is it a binomial? And then you're going to check to see, is what I'm looking at a trinomial? If it's a trinomial, there were really two ways that this could go. Some were just that ax squared plus bx plus c patterns where we ended up getting a binomial times a binomial. The other trinomials we saw were ones that fit into that perfect square pattern. So is it an a squared plus 2ab plus b squared? If it's one of those, we're going to factor to be a binomial squared. The difference that's going to help you identify these is the first term in these aren't necessarily a perfect square, but here it has to be a perfect square. Again, the last term isn't necessarily a perfect square. Here the last term has to be a perfect square. That's how you can kind of distinguish the difference between what type of trinomial you're looking at. But it's possible that you have a perfect square and a perfect square and you don't have a middle term that is twice the product of what's inside. So you could have a perfect square in the first and last positions and it ended up being really one of these types. So you identify, is it a binomial, is it a trinomial? And now you've learned, what do I do if I see a 4-term polynomial? If you see a 4-term polynomial, you're going to factor by grouping. You may have to reorder the problem so that it can be factored, but that's what you're going to look for. And the last step is you're always going to want to check to see, last, are any of the factors that remain still factorable? So I'm going to write last, keep factoring. So if you end up factoring, let's say a 4-term polynomial, and you get a binomial that's x squared minus 4 times an x plus 8. And that's what you end up getting from your 4-term polynomial. Well, if you look at that x squared minus 4, I hope you recognize that's a binomial, that's a difference of squares. So if you had those two factors, this one's not done yet. That could factor to be x plus 2 and x minus 2 times x plus 8. So that factored to be that times that. So whenever you're factoring completely, always look for monomials first, Second, identify the pattern. Binomial, trinomial, or four term. And then the last step is keep factoring if you can. And you may encounter some difference of squares that pop up as a binomial factor of something. So let's do some examples in the next video.